Project 3 Innovative Design of Scooter. Task 1 Wheel Pin Design. Lecturer, Li Huachuan. Hello, students. Starting from this class, we will learn innovative design of scooters. First of all, we should understand why we should innovate. Innovative design refers to a practical activity that gives full play to the creativity of designers and designs with scientificity, creativity, novelty, and practical achievements. Science and technology are the primary productive forces, and innovation is the internal engine of scientific and technological development. If you don't innovate, you will fall behind. Today, China breaks the technological blockade with innovation and gathers the majestic power of innovation with a feast of science and technology. Innovation leads development, shapes dreams, and brings confidence and pride. So how was the scooter invented? In 1990s, in order to solve his traffic problems, a German worker installed 2 wheels on an aluminum sheet, and then added a flexible metal handrail to a scooter to take him to work in the railway station every day, but he was initially despised by passers-by and colleagues. But before long, an investor came to the door, and he thought that this kind of walking scooter had a very good market opportunity. So scooters were invested and became popular all over the world. The basic process of design is generally as follows: first design sketch. Then analyze the mechanical principle, design and improve the structure, and finally use digital technology to simulate and verify. First, let's understand the functional requirements of the scooter. The scooter is driven to move forward by thrust generated by one pedal, and the brake pads of the rear wheels are pressed by the foot to generate friction to make it brake. When moving, the front of the scooter and the pedal form an included angle of 80 degrees. The front of the car can be folded down in a horizontal state. The structure of scooter can be roughly divided into front upper frame assembly, front lower frame assembly, pedal assembly, and wheel assembly. In this class, we first design the wheel assembly. The wheel parts given in this task are wheels, brake pads, springs, and rear axle brackets. So please think, what parts are missing? Now, give some tips. 1. How to connect the axle frame with brake pads and springs. 2. How to connect the axle frame with the wheels. 3. How to ensure the stability of wheels and reduce friction. According to the tips, combined with our basic knowledge of mechanical design, we can find the answer. 1. The shaft frame is connected with the brake pad and spring through a pin shaft. 2. To ensure the smooth rolling of wheels, it is necessary to add rolling bearings. 3. The axle frame and the wheel are connected by bolts. In today's class, we first design pins and gaskets based on the top-down design method. So what is a top-down design? There are 2 basic patterns of design. One is bottom-up design. It means that after all parts finish, the final assembly is carried out. The defect is that when the design of a part changes, it is difficult to update other related parts synchronously, mainly suitable for simple assembly. Another design pattern is top-down design. It uses the parameters of the previous model to finish of the next associated model, which saves the verification of dimensions and makes the design more reasonable and standardized. The advantage is that when the upper model design changes, it can be quickly transferred down to the lower model to complete the change synchronously, which greatly improves the design efficiency and is suitable for complex assembly. The key points of pin and gasket to be designed in this class are as follows. 1. First, measure the relevant mating dimensions with the shaft frame. 2. The positioning surface and process chamfering can be added to the pin shaft. Next, we will open UG software and learn how to design pins and gaskets based on top-down. First, open the wheel pedal assembly. Click Assemble and New Component. The model name is pin shaft. Note: the folder must be placed in the same folder as other parts of the assembly. Set the reference set to model. And click on OK. Right-click to set the pin as the working part. Click Wave Geometric Linker and select the pinhole on the shaft holder to unassociate. Then click on OK. Click the Part Navigator, and the copied curve has entered the Part Navigator of the pin as a feature. Click the Home. Stretch and select the copied compound curve to stretch and reverse, then stretch thickness according to the height of the shaft holder. Defined as 60, then apply. Click the link curve again. The offset distance is 3. The height is 3. We create the step surface of the pin and Boolean merge. Click on chamfer angle 0.5. Here, we find that the pin shaft is not collinear with the pin shaft hole, which shows that there is a problem in the stretching of the pin shaft. Go back to the assembly. Click the Wave Geometric Linker and select the pinhole on the other side to unassociate. Move the second compound curve upward. Double-click Stretch and specify Vector again. And select the center of the 2 points. OK, recreate the vector. Well, based on Wave Geometric Linker, the pin design is completed. Click the Assembly Navigator and set the assembly as a working part. We observe that the width of the axle holder is larger than the width of the brake pad. So it is necessary to install gaskets between the axle frame and the brake pad to ensure the fastness of the assembly. First of all, it is necessary to measure the width of the axle frame, 32, and the width of the brake pad, 30. So it can be judged that the thickness of the gasket is 1. Click New and the model name is Gasket. Then click on OK. Double-click the gasket. Click the Wave Geometric Linker and select the arc of the pinhole of the shaft holder. Here we will check the association to see what the association does. Check association and click on OK. Then click Stretch. Click the Part Navigator. The arc on the shaft holder has been linked to the gasket feature. Click Stretch and select the compound curve with a distance of 1. Note that the X-circle of the gasket needs to be offset. Select Bilateral, End with 2. And click on OK. Just now, we checked the association in the link curve, so what is its function? Let's take a look at it together. Double-click the assembly. Double-click the rear wheel axle holder. Open the component navigator and change the round hole of the axle holder. Click Resize Face to change diameter from 5 to 7 and click on OK. The pinhole of the shaft holder becomes larger, and double-click Assembly to hide the brake pad. We can see that the diameter of the inner hole of the gasket also changes with the increase of the pinhole. Because the tensile curve of the gasket comes from the pinhole on the shaft holder, when the holes of the shaft holder change, the diameter of the gasket also changes due to their relationship, which is the meaning of correlation in geometric linker. When the reference part design changes, the next part will also change, which is very convenient for design modification. Okay, this is the basic operation method of designing pins and gaskets based on the top-down design pattern. Have you learned to design pins and gaskets based on top-down mode? Please answer the following questions.